Hey, ladies and gentlemen, this is Ms. Humbert here, and today we're going to be doing Unit 6, Notes 2. So we're going to be talking about exponential growth. So we're going to be graphing, modeling, and applying exponential growth to our functions. So let's go ahead and let's take a look at what that's going to look like. So first of all, here's what exponential growth looks like. It takes the form of y is equal to c times 1 plus r raised to the t power. So c is the initial amount. That's what we're starting with when we start our problem. R is the rate of change. Now typically when you're given a rate of change, it's given as a percentage. You cannot put it in the math problem as a percentage. You need to put it in the math problem as a decimal. So you need to move your percentage left 2 places. And we'll take a look at more of that later in this lesson. And t is going to represent your times. Typically your time is represented in years. And one thing to point out is that your c value is always going to be your y-intercept. So that's where you're crossing the y-axis. So let's go ahead and let's take a look at number 1. So c is equal to 8 and r is equal to 0.45. So let's go ahead and let's plug it into the formula. So we have y is equal to 8 times 1 plus 0.45 raised to the x power. So what I'm going to do is I'm actually going to take the work to add that out when I write my equation. I'm not just going to leave it like that. So I'm going to make it 1.45 to the x power. And then when I go to graph it, it's just like you were graphing it on the previous note sheet. So you're going to make 0, 1, 2, 3, and 4. And then you're going to take each of those values and you're going to plug it in for x. You're going to plug in 0 for x. And when you do that, you get 8. Remember, I always suggest you plug this in along with me so that you know you're doing it correctly. And then you get 11.16, 16.82, 24.39. Again, if you're not sure how I'm getting these numbers or how to plug them in, please take the time to talk to me about it. And then you get 35.36. So now we're going to go ahead and we're going to graph those points. So here we're going over 0 and up 8. So we're crossing at this point. Then we're going over 1, up 11.6. So it's going to be just over halfway to 12. Then we're going over 2, up 16.82. So it's almost all the way to 17. And then we're not at 24. So then what we want to do, we're going to go up like this. Okay? All right, let's go ahead and let's take a look at number 2. So for number 2, we have c is equal to 6 and r is equal to 1/3. Well, what I'm going to do is I'm going to convert 1/3 to a decimal. So all that is 1 divided by 3. Well, 1 divided by 3 is 0.33. So when we write that in our equation, we have y is equal to 6 times 1 plus 0.33 raised to the x power. Then we end up getting y is equal to 6 times 1.33 to the x once you've added those two together. So then we're going to again go and create a chart 1, 2, 3, and 4. So now we're going to plug in each of those exponents for our x's, just like you did on the previous note sheet. So when you plug in 0, you end up getting 6. And then you're going to do 6 times 1.33 raised to the first power, that's 7.98. And then you're going to raise it to the second power, which is 10.61. Then you're going to raise it to the third power, 14.12. And then to the fourth power is 18.77. Now, I know I went through that a little fast, so if you're not sure how to do it, please come talk to me and let's take a look at it together. So now you're going over 0 and up 6, and you're going to plot this point right here. Then you're going over 1, up 7.98, so that's almost all the way to 8. Then you're going over 2, up 10.61, so you're going to go just over halfway to 11. Over 3, up 14.12, that's just past 14, right about here. And 18.77 is almost all the way to 19. So then what we're going to do is we're going to go ahead and we're going to have this sloping upwards as such. So when you're doing exponential growth, all of your graphs should be sloping upwards. If they're not sloping upwards, then you did something wrong. So go ahead and make sure you're checking that out. All right, let's take a look at number 3. So now we're going to look at some applications, which is kind of where this gets interesting and I think a little bit more fun because you can see how it's relevant. So there were 294,105 females. So to me, this is going to represent our starting value. This is our C in high school sports. Since then, that number has increased. That's why we're using exponential growth, because it's increasing, it's going up at 8.5% per year. Now remember what I said, percents are no good. So what we're going to do is we're going to take that 8.5% and convert it to a decimal. So I'm going to move it left 2 places. So then you're going to get 0.085 when I move it left 2 places. Again, something you're unsure about, ask questions. I'm here to help, okay? So let's go ahead and put it in our equation. So y is equal to our c value, which is 294,105, times 1 plus our rate. Again, I'm going to use the decimal version of 0.085 raised to the x or t power. I don't care which one you use, just pick a variable for the exponent. Then we're going to take and actually add those two together. So we're going to have y is equal to 294,105, and then you're going to take and you're going to add these two together, and you get 1.085 raised to the t power. So that's your equation. That equation, you could plug in whatever many years you want for t and plug it in, and that would give you your answer. So let's take a look at this. According to the equation you wrote, how many females participated in sports in 2005? So what we need to do is we need to figure out how many years passed between 2005 and our starting year of 1971. So we're going to take 1971 and subtract it from 2005. So in my calculator, 2005 minus 1971. And that gives you 34 years. So that's going to be my t exponent is 34 years. So I get y is equal to 294,105 times 1.085, and that's going to be raised to the 34 power. So now what we want to do is plug that into our calculator. Now here's where rounding gets tricky. We don't want to say that there's 0.3 of a person or 0.2 of a person. So what we want to do is look at that decimal point. If the decimal point is 4 or under, you're going to keep that whole number the same. If it's 5 or above, you're going to round that last number before the decimal up 1. So go ahead and punch this in your calculator. See what decimal you get. When you do your rounding on this, you should get 4,711,004 females. If you rounded it correctly, that should have been the answer that you got for that one. Next, let's go ahead and let's take a look at number 4. The city of Farmington has a population of 21,087, and it has a growth rate. Okay, it says the word right in there. We have to use exponential growth at 1.9% per year. Again, decimals we want, percents we don't. Okay, so I'm going to convert that into a decimal. So I moved it left 2 places. I end up getting 0.019 for my rate. My starting value comes from here, which is going to be c. So now I'm going to plug it into my growth equation. So I get y is equal to my c value, which is 21,087, times 1 plus my rate raised to the t or the x power. It's up to you. So then you end up getting y is equal to 21,087 times 1.019 raised to the t power. So this right here represents the equation for the population of Farmington as it grows year by year. So here it asks us to predict the population in 2013. So we need to figure out how many years passed between 2010 and 2013. And when you do that, you figure out that it's 3 years if you take 2013 minus 2010. So we have 21,087 times 1.019, and that's going to be raised to the 3rd power. So you're going to type that in your calculator. Again, you're going to get a crazy decimal. We don't want to talk about 0.3 of a person. So please make sure you're checking your rounding. So go ahead and type that in your calculator and see what you get. You should have gotten 22,312 people. Okay, so I want you guys to go ahead and calculate the population of 2017 on your own. You should do the same exact thing, but this time you're going to use an exponent of 7. All right, let's take a look at this compound interest formula. So this is another one that also implies exponential growth. This is a unique one, and you know you need to use the compound interest formula if ever in the word problem it says compounded. That means you need to use the compound interest formula. Okay, so let's go ahead and let's take a look at this. So your A represents your ending amount. That's the value that you're going to get after how many years. P represents your starting amount. So that's however much money you're putting in the bank. R is your interest rate. Remember, if it's ever given to you as a percent, you have to convert it to a decimal. N is the number of times it's going to be compounded per year. That's what we're going to make in this chart right here. And T is going to represent the number of years that you're leaving it in the bank. So if we're talking about daily values of n, okay, so if it's daily values, think about it. There's 365 days in a year. So then your value of n would be 365. If it's weekly, there's 52 weeks in a year. If it's monthly, there's 12 months in a year. We're talking about quarterly. If you think about quarters, there's 4 of them in a dollar. So quarterly is 4 times a year. Semi-annually is 2 times a year. And then 1 is for annually. Okay, last but not least, let's take a look at these two compound interest formulas. So Maria's parents invested $14,000. So that's our P value. That's our starting point right here. And then at 6% per year, well, I want to convert that into a decimal. So my rate is going to be 0.06. Compounded monthly. So compounded monthly, that means that my N is going to be 12. How many where they'll be in 10 years? Well, that means that my T is going to be 10. So I just pulled out each of those parts of the problem. So we're starting with $14,000 per year, then 1 plus our rate divided by our number of times per year raised to the exponent of our number of times per year times the number of years. So for the most part, you can type this whole thing in your calculator. The only extra step you have to do is to actually multiply out that exponent. So then you get 14,000 times 1 plus 0.06 divided by 12 raised to the 120th power. So you have to actually raise that exponent. And when you do that, here's what you end up getting. So I want you guys to go ahead and plug this in your calculator, exactly how I do it, or how it's written here. And when you do that, you should get $25,471.55. Whenever we talk about money, we round to 2 decimal points, which means you need to look at the third decimal point to figure out how you're going to round it. If rounding is something that confuses you, please come talk to me so I can help you with it. Next, let's take a look at number 6. Determine the amount of investment if $300. So that's going to be my starting P value. Is invested at an interest rate of 3.5%. So I'm going to go ahead and convert that into a decimal. That's going to give me 0.035. For my R, semi-annually, if I look at my chart, that means that N is equal to 2. Whenever words end in LY, typically that's telling you the number of times per year. And then for 22 years, so my T is equal to 22. So now we want to go ahead and plug this into our formula. So we have 300 times 1 plus our rate, which is 0.035, divided by our number of times per year, which is 2, and raised to the 2 times the 22. So again, you want to take that extra step to actually multiply out your exponents. So we're going to get 300 times 1 plus 0.035 divided by 2 raised to the 44th power. So you can go ahead and you can type that into your calculators. So do that right now. Type it into your calculator. And when you type it in, you should get $643.63. Again, money rounds to 2 decimal points, and watch your rounding. So that concludes your note video today. Please make sure you get that Schoology quiz taken. Thank you.